Okay, so today we're going to be talking about the units of heat energy. Yesterday we talked about how heat flows, but you can actually quantify and measure the amount of heat something has. And so there's actually two major units of heat energy. Let's take a look at this first one. So this first one is called calorie. Calorie is a specific unit that was designed specifically for capturing heat. In fact, it's a made-up unit. This unit was made by taking 1 gram of water and heating it up 1 degree Celsius. When we did that, the amount of heat that went into the water we defined as 1 calorie. You may have heard of calories before. When you eat something, there's usually a nutrition label. Those are actually similar to calories, but actually they're not the same. What do I mean by that? Well, there's another kind of calorie that has an uppercase C. It's also called calorie, but it's actually 1 kilocalorie, or 1,000 lowercase calories. This is what shows up in your nutritional labels. So when it says that your Rice Krispie treat is 80 calories, it's not actually 80 lowercase calories. It's actually 80,000 lowercase calories, or 80 kilocalories. Kind of a scary thought. Is there another unit? Well, yes. There is one other unit, and this unit is called joules. This is the SI unit, or the International Standard System of Units, and so this particular unit happens to be a compound unit. What do I mean by this? Well, this joule actually represents something fairly complicated. A joule actually is equivalent to energy, and according to Einstein, energy is actually mc squared. So that would have units of kilograms, meters squared over seconds squared. So a joule actually is this compound unit. You don't have to worry about the actual units that much until you get to physics. But this joule actually has a combination of these types of units. Okay, welcome back. And let's take a look at a conversion. So I have 10 grams of gasoline, and it releases 8,500 joules of energy when we burn this gasoline. So it's a combustion reaction. And the first thing I'm going to ask you to do is to convert this into kilojoules. Now, what's the difference between joules and kilojoules? Well, there's this prefix there, and it has a little K in front of it. I'm assuming you know what a kilo is, but if you didn't, there is a little section on the back that has all the different prefixes that we've used, and it should give you a little hint as to what kilojoule does. So, I'd like you to talk with a partner and try to set up a little T-chart for me. I will get you set up, and I will say it should look something like this. Alright, so what goes in this top left corner? Our starting value, which is 8500 point joules. I know I want joules on the bottom, and I want kilojoules on top. How come I didn't use the 10 grams? Grams is not a form of energy. Grams is a form of mass. Can you convert it into energy? Yes, if it got converted completely into energy, then you would use E equals mc squared. And that typically only happens in like a nuclear reaction. Okay? So you would never take mass and convert it directly into energy. So this kind of energy is not a mass to energy conversion. This is an energy to energy conversion. Does it tell us how much energy is actually released? Yeah, 8,500 joules. I can change those joules into kilojoules. But what does kilo mean? Kilo is 1,000. Does that make things bigger or smaller? Bigger. Kilo makes things bigger. If you look on the little chart there, it's 10 to the third, or a positive 3. It makes things larger. Okay? So which is the bigger unit? Kilojoules or joules? Kilojoules. So the 1 typically go with the larger unit, and the 1,000 goes with the smaller unit. Fewer big things are equivalent to more small things. Okay? Just like $1 is equivalent to 4 quarters. Tells me that dollar is a bigger unit than quarters. Okay, let's cancel out our units. Joules cancels, and all we're going to do is divide, and we get 8.500 kilojoules. Mr. Chen, what are these little zeros at the end? Well, I have 4 stick figs here. I need 4 stick figs on this side. How did you do? Any questions for me? Shall we try another one?
Yes.
Let's try another one then. Okay. Next one. Can I erase this? Okay, it's going away. Second one. I'd like you to convert 8,500 joules into calories, and then I want you to check in. Okay, so let's set up a T-chart, and what should go into the top left corner? What should we start with, I guess? What's easier? Do we want to start with joules or kilojoules? Joules. It's easier to start with joules because we have a direct relationship between joules and calories. And what is that relationship? 1 calorie.
Is 4.184 joules.
All right. Very good. Units cancel. If you don't know this number, obviously you can find it on the back of the periodic table. And then all you do is divide. And what answer do we get? 2,032 calories. How was that? Not bad? Any problems? Okay, there's one last thing I want you to do. And I want you to convert this into kilocalories. Alright, so let's check in, and what is the natural starting place that's easiest to start from? Calories. And we're going to take our answer from the previous problem, assuming that's correct. And we're going to convert these calories into kilocalories. Which is the larger unit? Here goes the 1, and it's 1,000. Units cancel, we divide. Answer here is 2.032 kilocalories. How did you do?
Good.
Not bad? Okay, let's move on. Okay, so let's do a quick check. I'm going to ask you how many kilocalories are in a jelly donut if it provides 110 kilojoules of energy. And this small hint is essentially a setup for you. It should look roughly like this.
That's a long one.
How's that? Alright, welcome back. Good trying. It looks like we've set it up really nicely. We did omit crossing off our units, so I'm going to go ahead and do that. Cancel our units. In fact, we can do something else here. We can even cancel out 1,000. 1,000 on top, 1,000 on the bottom. Would you agree that multiplying by 1,000 and dividing it by 1,000 should cancel out? Yes. Very good. So all we need to do is 110 divided by 4.184, and that should give me an answer. What did we get? 20 what?
26.3.
Ooh, very nice. Kilocalories. Excellent. 3 sig figs. Nicely done. How was that? Swell. Swell, swell, swell. All right. Let's do one last one. And this will be kind of like... All right. Good job, guys. Looks very good.
This is